With this video lecture series, we are starting your DSTL subject which has the code BCS 303 and we are starting from unit 1 which is set theory. Now you must be wondering what is a set. So collection of elements which are discrete from each other and fall into one common umbrella. Now you must be thinking discrete from each other? Yes. Suppose I write this example of 5 vowels A, E, I, O and U. Now they are discrete in the sense there is nothing between A and E. You cannot have an element like A2, A.2, A.5. Similarly, there is nothing between E and I. They are discrete from each other, yet they follow one single rule and they fall in one single umbrella which is called a vowel. Now, similarly, I have written one more set, first 5 even numbers. Now, you must be wondering why are we taking only the capital letters? So, this is the rule, we can name any set using a capital letter only. Now, this is how we represent a set, and this way of representing a set is called roster form, in which we simply put the elements in curly braces separated by commas. The other one, this is the one way of representing the set. Now, other one is set builder form. First of all, let's know the need of this second way. Suppose you have a set having n number of elements, having infinite elements. Suppose I tell you to write first 500 prime numbers. You cannot put them in curly braces and separate it by comma manually. It will take a lot of time and manpower. So, set builder form is a single statement through which, as the name suggests, your set can be built. Suppose I take an example of first 50 even numbers. This can be written as E, where an element x such that x is divisible by 2 and x is less than equal to 50. Now this single statement builds all of your set which is first 50 even numbers. So this is your first way of representing a set which is roster form, and this is the second way of representing a set which is set builder form. So we have come across this topic. Now if I talk about types of set, there can be n number of sets. First of all, these are divided into two big classes, infinite and finite. We will be taking example simultaneously. Infinite sets, if I say number of stars in the universe, okay, number of natural numbers. We don't know how many natural numbers are existing. We have a single term for it called infinite, but it is also not defined. So, infinite set and finite set. Then under finite set, we have multiple types of sets. First one is singleton. As the name suggests, it only has one element in it. Next is null, which has no elements in it. Then subset. Suppose I have written a set R called A, B, C, D, E, F. Now I make another set out of it, R dash, and put A and E in it. Now as you can see, these elements belong to this set also, but not all the elements are there in this set. But this set can be derived from this set. Hence, R dash is subset of R. R dash is subset of R. This is the sign of subset. Now, power set. Suppose let's come back again to the subset. I take a set A and write these three elements in it. Now, how many subsets are possible? Firstly, null set. Null set will always be a subset of any set. Then 1, 2, 3, 1, 2, 1, 3, 2, 3 and the set itself. These all are the possible subsets of this single set which has 3 elements. Now if we count the subsets, these are 1, 2, 3, 4, 5, 6, 7 and 8. Can you see any relation? Yes. 2 to the power number of elements in the original set will be the count of subsets. Okay. Now the set of all the subsets of any set is called power set. Okay. You took a set, you created the subsets, all the possible subsets, you counted first how many subsets will be there, then you listed all of them and then you put them in a big curly braces and that will be your power set. One more kind of set is there which is called universal set, which has all the elements if we talk about a particular context. Suppose I write these sets. Set A, E, D. I write another set F, G, H. And both these fall into one big umbrella called alphabets. So here universal set is alphabets.